So I'll start with this one. 5 is that cistern, right? No, it's not. 5 is that, okay, got it. The volume of toilet paper, okay, it's asking specifically for volume. On a brand new roll, which has an outer diameter of 6 inches and an inner diameter of 1 inch and a length of 7 inches. Like, find that volume. All right, so imagine a lot of you need to have this drawn out, right? So I'm imagining it standing up like this, and you've got something like that. Okay, sorry about that. It's not the greatest piece of art. But I know that the diameter on the outside is 6 inches, and the inner diameter is 1 inch. So I know that this is 1, and I've got 6 on the outside. All right. So when it comes to volume, I'm gonna approach it this way. Total volume. Volume is easier than surface area. Okay. I'm gonna go volume of large minus volume of the small one. So I'm thinking 2 cylinders, right? I'm thinking there's a big one, and I need to take away the hollow part inside. I need to take that away. So my radius, my capital R, if there's 2 radii, I'm using capital R, lowercase r. That's normally what I do. So I go 3 for that, and lowercase r is 0.5 or half. Okay? Everything is in inches, so I'm going to double check that. I don't need to do any converting. So here we go. Cylinders, it's pi r squared h. The h is the same, right, guys? Height is what? 7? So for the small cylinder and the large one, it's both 7. So I'm just going to keep it the same. So minus pi r squared h. So it's pi 3 squared 7 minus pi 0.5 squared 7. So I'm taking away the small hollow part there. When you type this in, so it's very important that you use your calculator properly, right? So second hat, that's your pi, if you remember from last year, 3 squared like that, times 7. I would strongly encourage you to do this in stages, okay? Minus. I'm going to do that again, pi times 0.5 squared times 7. So that's the little cylinder. If I subtract it, so now I'm going to go copy paste. I don't know if you remember it from last year, right? Copy paste that one. You go minus, go up arrow, take away that small one, and you get 192.42. And now we're in volume, right? So it's cubic inches. So this one is, both are the same shape, right? We subtract, that's just what you get there. Do you need a refresher on backwards? This one is a little messy because it's surface area. I might do this here. Surface area of a cylindrical septic tank. Okay, it's a tank, so it's closed everywhere. Okay, so I make sure I make note of that. 2 pi r squared plus 2 pi rh. That's what the surface area calls for. So this is 875. And because my diameter is 10, my radius is 5 feet. I make note of that. So it's 2 pi 5 squared plus 2 pi 5h. That's messy, right? How you want to clean this up, it's up to you. Okay, maybe, I know my key did weird things, kept pi where it is. I'm going to show you how that it's totally fine to just go like this. Right? You actually type in all these numbers in, you get 157.079 and something. And then here you can clean this up 2 times pi times 5. So that's 31.415 something h. So don't forget that it's still multiplying h there. Okay. And here you have to do some algebra. So h is attached to that one. These are multiplying, so you can't do anything with it yet. First tackle this number that's in front of it, right? That's adding to it. So I'm going to go minus 157.07 something. Cancel that out. And so on this side, I go 875 minus, I take away the 157. So I'm left with 717.92 something. On the other side, I'm left with 31.415 something, right? And now I can divide both sides by that. I'm dividing, I'm not subtracting, okay? Lots of dots, right? It doesn't matter. That's what we want. We want to use all decimals. So at the end of the day, you got to go 717.92 divided by 3141, right? You hit enter and you get 2285. So my height is 22.85, and we are in feet, so there was no converting necessary. Okay? So this is another way of doing it. If you don't like to keep the pies, if you like to eat it instead, it's not funny. You do it that way. Now, number 3, I will do because it is trickier. I would like you to find your own way to make things work out. So when you look at my key, please don't erase what you've done and recopy it. Like, try to figure out your own way. I actually prefer that. It's sometimes hard for me to follow what you've done. It's like, wait a minute, what did you do there? Oh, okay, you're adding it here, but then just subtracting it later on. That's fine, okay? So find the total surface area and the volume of this composite shape. So let's do the surface area first, because I think my key was a little weird, right? So total surface area, how about we tell ourselves what we're going to do first? We're going to do the surface area of the box, but we're going to omit this square right here. Okay, it's a cube, by the way. A cube is means that all sides, everything is 16. Okay, that's what that means. So we're going to go surface area of the box minus the top. So I don't want this top square. Plus the pyramid. I'm just going to go, because I don't want the bottom of this pyramid. If I come from the pyramid's perspective, I don't want that bottom. So I'm just going to go LSA, lateral surface area of the pyramid. So I'm kind of telling myself that's what I'm going to do. Okay? So let's do the surface area of the box. Watch this. Just maybe watch for now. If you want to copy it later, 2 times length times width plus 2 times width times height plus 2 times length times height. That's what a box usually is. This is a cube, so you probably looked at my key and you're like, well, how did he come up with b squared, right? Like I did this. Like 5b squared, like what is that? Well, how many sides does a box have? 6, right? And they're all squares, so I just called them all b. So 16 times 16, that would be the area of just one face, and I just multiply that by 5. That's what I did there. But if you don't like that, if you don't, it's like, what is that? Because I haven't dealt with cubes a whole lot, right? So you can use this one, except for, I don't know if you remember, this is top and bottom, and these are the sides, okay? So I'm just going to say, if you're going to keep it this way, you got to go minus a length and a width, right? You got to take one of these faces away if you're going to keep the whole thing. Some of you are like, Mr. Dirksen, I know I'm just going to omit that too, and then I don't have to worry about subtracting. Okay, guys? That's fine as well. So I'm just going to say plus lateral surface area is, you got to help me out on this one, is it 2 times A times S, right? Mr. Dixon, you did B on your key here. I'm looking at it. It doesn't matter. Just stick with a letter that works. I think I used A when I gave you the formula, so I'm just going to do this part right here. On my work here, maybe, just to show my audience, I'm going to be like, this one can go with this one. Okay, so instead of 2 length and widths, okay, that subtracts a length and a width, so I'm really just left with one of them. So this is one way of showing what you're doing, okay? Length and width is 16 times 16 plus 2 times 16 times 16 plus 2 times 16 times 16. Everything is 16 plus 2 times A. So this part right here is also 16. So the base of the pyramid is 16. Oh, and the slant is given. So that's pretty convenient. Slant is already given. Slant is along the face, okay? So boom, that's how you do it. And you can tell that this is A squared, right? This is A squared. So there's really 5 of those A squares, like 5 faces of that cube that are being added here. What's 16 squared? 256? It's too early for me to, yeah, it is 256. So it's 256, and then 2 times 256 is 512. This is also 512. This is 20 times 16, that's what, 320? I think so. I think I'm doing good. If you add up all of these, 512 times 2 plus 256, that's 1280 that I get out of this. So that's like the cube without the top, plus 320. If I add 320 to it, you get 1600. What are we in? Centimeters? Centimeters squared. Are we doing okay? Jackson, like you're doing, like this is easy. Why are you doing this again? Like seriously, I'm falling asleep here. Well, if it's easy for you, way to go. Like, then you should be happy, okay? Total volume. TV. Volume is easier. Do I add or do I subtract? I add in this case, right? There's no hollow part missing. So I got to go box, so volume of box, plus volume of pyramid. That's it. Okay? What's the volume of the box? Length times width times height. Okay? So it's 16 times 16 times 16, or 16 cubed, plus. What's the volume of the pyramid? It's base times height. Uh-oh. I don't have the height, do I? So when this happens, guys, you need to show me that. Okay, you need to show me what. So you take this. We want, if you have a marker or something, we want that, okay? We want that height here. That is the height. So we need to figure it out. Am I going to have enough space here? I think so. So I'm going to do this. Cut it, cut it. So I'm cutting out this triangle that goes into the center of the pyramid. The 10 is here. What's this here? 8, right? It's half of 16. And it's all centimeters, so I need the height here. If you need the height, you're going to go hypotenuse minus the other leg. Okay? And that ends up being square root of 36, which happens to be a whole number, so we're very happy about that. We have the height now. I'm going to highlight that. That's 6. What's the volume of a pyramid again? It's base, right? Area of base. So 16 times 16 times the height. I should have written out the formulas. I know that. Divided by 3. So if it's a slanted shape, divided by 3. Okay. So 16 cubed is 4096. I did that all in my head, guys. Is that impressive or what? No, I'm just copying off of my key here. And this is 512 if you do this right. If you add these two, you get 4,608 centimeters what? Cubed, yes. So this is my final answer. No decimals. We're really happy about that. Don't get too used to that because most of the time it's not. Okay. So, surface area volume. Not so far they didn't ask for surface areas with hollow shapes in it. That is the one that throws a lot of us off when there's a hole through a shape. Okay. So we're going to do that one next. I hope this is helping you. Some of you are like, oh, I needed this last night to fall asleep. I have a YouTube channel that can help you out with that. I'm going to skip 4 for now. If you didn't do it, you do it. I'm going to go to 5. Okay. That shape, that hole that goes through it is not a pyramid. It is not a pyramid. Okay? And how do you know, Mr. Dixon, what's the difference between a pyramid? A pyramid has a square base, and then at the top it's like a tip, right? If you think about it, there's a triangle here, and that triangle goes right through. Pretend like somebody shot a triangle-shaped object through this gel box, right? Like it shot it through and it left a hole the shape of a triangle all the way through. Okay, that's what happened here. So what is it asking? Please say volume, please say volume. No, it's asking surface area and volume. Okay, so we're going to tackle surface area first. All right, let's do it. And I probably will deviate from my answer key on this one because that's just how I work. I fly, I go freestyling most of the time. The rectangular solid, the dimensions of the base of a rectangular solid are 5, 8, and the altitude is 12. So we are going to imagine that this is 5, this is 8, and this is 12. Got it? 5, 8, 12. By definition, length, width, height. Okay? A hole extending from upper base to lower base in the shape of a triangular prism whose bases are equilateral triangles. This is important here. Equilateral triangles, and they all have an edge of 3. So I don't know where you want to put this, but it's 3, 3, 3 all around, right? We know that this thing is 12 high because it matches the box. So let's see here. Let's try to write this out first. Total surface area. Surface area is something that you can see, guys. Okay, so I'm too big to fit into this hole, right? But so surface area is all around it on the outside, and also what kind of shape is created by the sides of this triangular prism? There are 3 rectangles, right? You need to add those as well. Those are part of the surface area. So if you were to able to turn this thing, I really want to 3D print this one day. I just need time. I have my son's 3D printer, so I might ask him, hey, can I borrow it for a second? But yeah, like there's rectangles on the sides, right? And what is missing? Like if you look at the top of this box, what is missing? There's a triangle missing, literally, from the top. And there's a triangle missing from the bottom, right? They're literally not there. So let's see here. I'm going to go surface area of the box. If you can copy this again, I don't know, you probably don't have room for this on here if you did this already. I'm going to see if I can find you some. If you want to do this again, if you feel like, you know what, your key made no sense, I lost you. okay? Page 27 is empty, so if you tell yourself, see page 27 for notes, if you want to do it there, that's fine. Surface area of box, okay, got it. Minus, I'm going to say 2 triangles, the top and the bottom. At some point, I have to subtract 2 triangles. Doesn't matter when you do it, okay? Plus 3 rectangles, okay? I see already, the key is very messy. It's like, that's like nerdy way of solving. Don't do it that way. Toss it, okay? If that's the one that you saw, I'm not too proud of that one. Yeah, sorry about that. Surface area box minus 2 triangles, top and bottom, plus 3 rectangles, because you can actually see those faces inside. Okay, so let's try this. Surface area box is 2 length width plus 2, and this is always that throws students off. Is it length, height, width, height? It doesn't matter. As long as you have length and width first, then it's either length, height, or width, height, but you have to have them both there. Both the length and the width need to be multiplied by the height if you're considering all faces, okay? Minus 2 triangles. How should we do this? I'm going to go like this, 2, and I'm going to put a big bracket like this. I'm going to go base times height divided by 2. Let's leave it like that for now. Plus 3, I'm going to go like this, length times width. Those are the rectangles. There we have it. And now let's plug in some numbers. 2 times 5 times 8 plus 2 times 5 times 12 plus 2 times 8 times 12. And if you like, you know, let's keep everything separate because some of us need to visualize what is this thing here. That is the box, right? This is literally just taking care of the box as if there's no hole in it. We're just going to, for now, just treat it as like the whole box. Minus. What can I do with, since everything is multiplying here and being divided by 2, I can actually simplify this further. Watch this. It's so satisfying. Right? It's like, well, why would I divide by 2 if I'm going to multiply by 2, right? So it's really just base times height. And here it gets messy. Let's draw the triangle out. It's an equilateral triangle, which means if I know the side of one side, I know them all. That's 3, 3, 3. So I can consider the base, okay? The base is 3, so I'm going to write that down. And what is the height? The height in this case would be that. So just that face, this is the height. How do I solve for it? Pythagorean theorem. Okay. So the height is, it's one of the legs, correct? So I got to go like this. Hypotenuse squared minus, what will I minus by? 3 or 1.5? 1.5, right? Like you got to work with the right triangle here. This one. So minus 1.5 squared. Let me see what I get here. 9 minus 2.25. So 9 minus 1.5 squared. So I get 6.75. Root of it. So I need to take the root second, x2, go up, paste it into the root. H is 2.59, and it keeps going. Please don't round just yet. Is everything, do we have units in here? Centimeters. All units are centimeters, sorry. So I'm going to highlight that one because this was an aside, right? So one of these triangles has a base of 3, right? One of the faces, and a height of 2.59. So I'm going to go, this is going to get messy, so I'm going to go times like this. And I would highlight that in here. Okay, so this takes care, this right here takes care of the 2 triangles. Okay, if you follow this along, this is going to take care of it. I'm going to subtract those 2 triangles. Plus, this one is going to be easier. 3, you want one of these faces out here. This measures 3 because it's along one of the faces of the sides of the triangle. So that's 3. And what is this? This is 12. Okay. So length and width, just go 3 times 12. And close it like that. All right. You're just going to have to trust me that all of this ends up being 392 minus this ends up being 7.794 ... So I'm not rounding yet, plus all of this ends up being 108. So I would say the hardest part is like telling yourself what needs to happen. And then it's just plugging in and carefully going through it. And this is 492.21 centimeters squared. That's the surface area remaining. Is that what we're getting? That's what I get. Any other ones? No questions? I hope that it's because I got this, not because you didn't do it. Okay. Did I assign the lunchbox one? How many of you did question 6 and you think you aced it? Not a whole lot of you. Okay. I can count with one hand. Okay. I would like to do this one because it has a half shape on it. And I would like to suggest how to deal with halfers. Okay. So let's do this one together. Maybe, yeah, I'll do this one so that you can do the next one by yourselves, okay? So there's a lunch box that has a half cylinder, so half a cylinder on a rectangular box. All units are in inches, so keep that in mind. Find the total area of metal to manufacture it. Total area of metal. What are you thinking, surface area or volume? Metal, surface area, right? Cardboard, metal, fabric, anything you need to cover. Even sod, guys. Do you know what sod is? It's going to come up again and again. Sod is grass, right? Like if you lay out grass in your yard, that is also surface area, okay? As soon as something has a depth to it, it's volume. Yes?
Sorry, about the last question.
Yeah.
Why did you add 108? Because it's part of the percentage substitution?
That's a good question. So the reason why I'm adding it, because you can go, like if you needed to paint this, you would now have to paint those rectangular faces because there's a hole of a triangle that's shot through it, and those rectangles are also to be painted. You know what I mean? Does that make sense? So that's why. So you were wondering why I added the 108, right? Yeah. So it needs to be added. So basically, the box needs to be painted all around and inside. So can we use that as our, like if you ask yourself, if I were to paint this thing, where would I need to put paint on, right? And the triangles are not there technically. You just see the shape, but you're not painting the triangle. Good question. I appreciate that. Anytime. All right. Let's do this one. Total area, metal required. And then there's a bunch of stuff. Let's just read it and then we'll deal with it as we get to it. Okay? What is the cost to produce 100 of these lunch boxes? So we're going to make 100 down the road. We're just going to focus on one at first, of course. If the average cost of flexible sheet metal is 49 cents per 36 square inches, okay, you're supposed to figure out the cost, right? How much would the company have to charge in order to make a profit? So these are questions that are going to slowly appear. So it's not just going to be surface area and volume, okay? Let's try this. So we're going to do A here. Total surface area. What needs to happen here? We would need the box without the top, correct? Box without top. I'm just going to say that. Without top. I'm just going to say that right here. That's going to take care of how we set up our equation, our formula. Plus, watch how I'm going to do this. I'm going to go half the surface area of a cylinder. And this is my suggestion here, to do the half in front of the whole, okay? The whole shape. We'll take care of half later at the end. Otherwise, it gets very messy if you do half, half, half everywhere. Sometimes students double half. They half too much, and then it's like, wait a minute, now it's way smaller than at the beginning. So here we go. Let's do the box. No top. So that means length times width, that's it. No 2 length times width. Just length times width, that's it. Plus 2 times length times height, plus 2 times width times height. So this is the box. You can square bracket that if you want, if you need to say, like, I need to portion this off. Plus half of the cylinder. So that would be 2 pi r squared plus 2 pi RH. And I need a break. I need a water break. So I'm going to say I set this up for you now. I'm wondering, can you plug everything in and get the right answer? That's right now the task, okay? So I'm going to stop there, and I'm going to allow you to do the rest. Don't use up the whole thing, okay? Because we need a little bit of space yet for B and C, okay? So please do that. And if you've done this already, you sit back and relax because you earned it, okay? From your grade 10 year, and grade 10 has been a while, right? It's been a long time ago. So we want to make sure we review that. Okay. If you plug this all in, yeah, by definition, it's length, width, and height. Like that's the order in which we go. So length and width is, there'll be 10 times 6 plus 2, 10 times 8 plus 2, 6 times 8. Okay, this takes care of the box. I don't include the top. okay, plus half 2 pi. What is the radius? I hope you figured that out, right? If this is 6, then the radius is 3. So the radius of that cylinder is 3. So you've got to go 3 squared plus 2 pi, 3. And what is my height in this case? If you look at that cylinder, it's laying down, correct? Yeah? So that's 10. So there we go. I'm just going to fast forward this part. So if you clean that up, the box you get 316, okay, this. And then this part, it's half of 245.044, and that keeps going, okay? And then you go 316, you figure out what half is, and so at the end of the day, you get 438.52 squared inches, okay? Why am I rounding? Because if it's A, B, C, and so forth, technically this answers A, so you can round to 2 decimals at that point, okay? Now B is asking what's the cost to produce 100 if you pay 49 cents per for every 36 squared inches. So we'll do that here. We'll go 100 times that, okay? And that conveniently just shifts the decimal over 2 spots, right? So this is how many squared inches are required. That's how much sheet metal you need to account for. I have one objection here, but I'm not introducing it just yet. Pay attention to this one. Often there's waste, right, guys? When you cut and make something, you usually have maybe sometimes you have a little bit more or some left over. So pay attention to this part, the wording. If a question says, add 5% to this to account for possible errors or to account for making a mistake, right, or for waste, you would add 5% to that if the question asks you for it. The easiest part is you would just go times 1.05. Okay, that adds 5% to it. I'll show you that later. But for now, this is it. This is required. This is how much sheet metal you need to make this happen. So now you need to figure out the cost. Okay, so before you do costs, what can you purchase this in, and what kind of quantities can you buy this? You have to buy it in 36 squared inches quantities. You can't do half or whatever. It has to be this. So I'm going to go sheets required. I'm basically going to take this and divide it by 36. Okay, so here we go. 43,852 divided by 36. You get 1218.11, and it keeps going. How many sheets are you going to need to buy? 1219 sheets. So this is the thing you have to always account for. What is this sold in? And what kind of quantities is this sold? Okay? So now it's the cost. 1219 times, that's super cheap, by the way, 49 cents for 36 squared inches. Anyways, I just made it up. Okay? 1219 times 0.49. So it's 597.31. Okay? That's before tax. I don't think I added taxes. No, that's what I have. So we'll deal with taxes in due time. Right now, we have other things to worry about because adding taxes is pretty easy. Okay? And C, how much should the company charge? Minimum to break even, you'd have to go 597.31 because that's how much you're going to have to account for to make these 100 lunch boxes. So you just divide that by 100. Okay? So you just divide that by 100 and you get 5.97 minimum. It's probably how they do the yearbook, right? Like they figure out like how much is like the minimum that they have to charge to break even. Okay? They probably do something like this, like it costs us, I don't know, how many thousands of dollars to make this many, right? So then they just divide it by the number that they're expecting to sell, all right? So I like to box this off a little bit. So for B, this was very messy. I'm not too proud of this one. But messy is like, I can't help it sometimes, just the way it goes. So that's B right there, and then C is just right here. So obviously they wouldn't make a profit. Let's do the last one here, and then I'll ask you to try some on your own. What time are we at? 11:30. Okay. This one is tricky, in my opinion. So a well is to be built of cement. It has walls and bottom that are 1 foot thick. So in a sense, this is 1 foot, and this is 1 foot. And I would like to add that inside here, okay, there's a 1 foot bottom here as well. Okay, so I'm going to write that out at the bottom here, 1 foot. The bottom of that well is 1 foot. Okay, so on the inside of this, it's 1 foot high. Okay, and so, and it needs to be painted with purple paint. Okay, the outer height is 20 feet, so it's 20 on the outside. The inner diameter is 10, so from here to here it's 10, so this is obviously not drawn to scale. How much cement is needed to create the wall? So if I'm asking you for concrete or cement, what are we thinking of? Volume, right? And it also gives it away that you want your answer in cubic yards, so that all of that kind of goes to show that is volume. So I'm going to say total volume required. Would you agree that there's 2 different cylinders? And there's something missing, right? This part, like when we're talking volume, like we're taking away that volume that's missing on the inside. So I'm going to go volume of large minus volume of small. Okay. And we're dealing with cylinders, so this would be pi r squared. Watch what I do with h. Are there 2 different heights, guys? The smaller has a different height than the big. So I'm going to go capital H, lowercase h, minus pi r squared h like that. Let's figure out the r's and the h's and all that, right? I'm going to do that over here. Capital R is, what do you think? What is it from outside to outside? It's 10 plus the 1 and the 1, right? So it is 12. Not very pretty here. Let's make some room. So it's 10 inside, it's 12 outside. So capital R is 6, lowercase r is 5. Okay, radius inside, half of 10, 5. Diameter outside is 12, half of that is 6. H is 20. What is lowercase h? It's 20 altogether, but the inside we're told has a 1 foot bottom, right? So otherwise the water is going to run out. So it's 19, okay? It's 19 on the inside. So this part right here, if you take away a foot from 20, you've got 19 there. So the inner, the small one has 19 for the height. So then we start pi r squared times 20 minus pi r squared times 19. Do this in steps. Don't rush. I know some of you just like to type in the whole thing in one shot. Yeah. Go ahead. I thought you were going to say you made a mistake. plus 20 times 20. So it's 226194 something. And I think this one is a good copy paste example. So I'm going to paste my previous work, just highlight it, and I will just replace this 6 with a 5. And I will replace the 20 with a 19 because you can just overwrite. Saves you a little bit of time. And now you just subtract it, copy, paste. So I'm going to go paste that one. I'm going to go minus, highlight the previous answer, and it's 769.69. What are we in? What units are we in right now? Cubic feet. Oh, almost. Almost fell for it, right? It would have been nice and convenient to just put cubic yards and be done with it, right? So I convert. Do you remember me telling you to write down this conversion ratio? If not, add this to your study sheet like now. What do I know? 1 cubic yard has how many cubic feet? 27. Yeah. Not 3. Okay? 27 because it's a cubic yard. Cancel, cancel. So basically what you need to do is this times 1, which is irrelevant, divided by 27. So it's 28.51. I actually made a mistake by rounding too soon here. But I'm just going to go dot, 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 okay? Over here. And then this is where you would round. Okay, we've got not quite 10 minutes left, but I want you to get started. You can work with your neighbor. I would actually appreciate if you work with your neighbor. We're going to go to the front. I'm going to mess with you a little bit. No, I like my comfort zone. Don't take me out of my comfort zone, Mr. Dixon. So 15, go to page 15. And your challenge is going to be page 15 all the way to 18. I took the time, I used a software called, I forgot now, something CAD. It's a program that allows you to make 3D objects and then you can 3D print them. So I just used it because I love it. AutoCAD or something CAD. If you're in that shop, you know what I'm talking about. Maybe. But anyways, so I gave you different angles of it because I know sometimes it's hard to like picture this thing. So if you think of this shot and that shot, it's exact same shape, but then you have it from different angles, okay? So I would like you to figure out the surface area and the volume. And I know 15 to 18, that means 1, 2, 3, 4 shapes. I would say if you get at least 2 out of the 4 done by tomorrow, and then even if you had a hard time with it, I'll take it. As long as this thing is filled in. Okay, I need it to be filled in. If you come to class and you're like, I just didn't know how to do it, Mr. Dirksen. I didn't even try. I beg to differ. I think you can start, okay? Keep in mind, please use this reasoning. I know what the whole shape is, and there's some of it missing. So I'm going to go whole minus what's missing. Don't try to figure out a formula. Do we have a formula for the donut part there? Just like that? No, I never gave you one like that. But you know that there's a big circle and there's a smaller circle missing. Okay, now we're talking, right? That's it for today, guys. I would say get started. You have some time to get started, okay?